Hello, my name is Jishin. I'm more commonly known as Jin. I'm a senior industry solutions architect from Alibaba Cloud Data Intelligence team. Today, I take the honor to introduce you AIACC. AIACC stands for Apsara AI Acceleration. It is a GPU acceleration engine developed by Alibaba Cloud to boost the productivity of multi-GPU cluster workload. It runs on Alibaba Cloud ECS instance to improve the efficiency of a GPU in distributed deep learning workload. It helps our customer maximize the return of investment for every single dollar they choose to spend on GPU. So you may be asking, is AIACC really that good? Let's take a look. Stanford University owns and operates a worldwide end-to-end deep learning competition benchmark. In 2020, AIACC has scored 4 worldwide records in training the MXNet using ResNet 50 model architecture with 128 V100 GPUs. Concretely, in order to reach 93% of validation accuracy, AIACC has achieved in 2 minutes 38 seconds. Now you may be asking, it sounds super fast, but is that going to be very expensive to use AIACC on Alibaba Cloud? The answer is no, it is not. We actually achieved the lowest training cost for achieving the world record-setting training performance. Training is only one side of the story in deep learning. What about inference? When you have model developed, you need to use the model to perform scoring tasks in a business context. Even in the inference category, AIACC has set world record performance, achieving 0.0739 milliseconds for each inference. And also the cost associated with each inference is the lowest in the benchmark according to the Stanford Dome Bench. So MXNet and ResNet 50 is more or less for research purpose. What about something more practical? Okay, let's take a look at MNIST. MNIST is a world-famous dataset. It consists of handwritten digits. For whoever wishes to get into deep learning, MNIST is probably the first dataset you will be learning to compile your own deep learning solutions. Now, I'm going to use MNIST as a dataset to try my own handwritten digit recognition program using 4 T4 GPUs with 64 gigabytes of GPU memories. I'm going to set the comparison environment to be identical between the one with AIACC and the one without AIACC. Let's take a look. Here I've got my training programs showing in Visual Studio Code. I have one version for Horvath and the other version for AIACC. In my Visual Studio Code, I'm showing you side-by-side comparison of same training program which I used to train my MNIST datasets. As you can tell, while I'm scrolling down and up, you notice the codes are identical except one line of import statement change. On the right-hand side is the import statement for using AIACC with codename Precious for my TensorFlow and Keras backend. On the left-hand side is the standard Horvath for running my TensorFlow and Keras convolutional neural network training program. Horvath is an open source distributed deep learning framework which is popular to the community when they wish to produce or run a distributed deep learning training. Let's go to my server. Here I've got 2 windows showing side by side. On the right-hand side is my Horvath environment, which runs open source Horvath for training the MNIST program on my 4 GPU instance. On the left-hand side is identical ECS settings, except this time I'm using AIACC to run my MNIST training program. Let's take it for a spin. I'm going to run my MNIST training program using Horvath on the right-hand side and show you the performance of a typical distributed deep learning on 4 GPU cards. The program has already started. I'm going to let it run for a while. You can already tell To complete each step, on average, it's taking about 10 milliseconds, 9 milliseconds, sometimes 11 or maybe 12 milliseconds per step. For this quick demonstration, I've set to run the program for 30 epochs or 30 iterations. We can already tell my training program has achieved more than 99% of the accuracy. Okay, the training has finished. With batch size 128, to reach 99% of accuracy, it took 40 seconds on Horovod. What about doing the same on exactly the same configuration using AIACC? Let's take it for a spin. By the way, this demo is run on completely identical ECS. Okay, our training program has already started. You can already tell by looking at the training progress, each step on AIACC is now taking around 6 milliseconds, sometimes 5 milliseconds, but it's quite consistent across my 30 iterations. Okay, the training has already finished on AIACC. Achieving the same accuracy using the same batch size on AIACC with same configuration, it took 25 seconds as opposed to 40 seconds using Horovod. Back to our slide deck. In fact, depending on the configuration of your environment, the GPUs you use, sometimes you can achieve much faster speed acceleration using AIACC. For example, in this multi-instance, multi-GPU card training, I have achieved nearly 100% of training speed increment using AIACC when compared to the same environment without using AIACC. This is the highlight of the difference in the two programs. The training program and architecture, the dataset, they're all exactly the same, except one line of import statement change. That's how simple it is to introduce AIACC into your own distributed deep learning workload. Now you may be asking, this sounds way too simple. It is the simplest deep learning 101 anybody choose to use for their experimentation. Does AIACC really work in real life settings? Okay, let's park that thoughts for now. I'm going to introduce you something more practical in real world. Here's the problem settings. We know the world has been affected by coronavirus, and the medical professionals are working hard to help patients get better or help them proactively diagnose the coronavirus infection. The challenge is most of the professionals are using CT scan to help them accurately diagnose COVID-19 symptoms. However, CT scan is expensive and is also very scarce resources. Not everyone can have easy access to CT scan, particularly in those developing areas. On the other hand, we have X-ray chest image, which is much cheaper to access and much easier to gain access to X-ray medical devices. However, even for a trained medical professional, it is a lot harder to diagnose coronavirus infection using just pure X-ray chest image. Here's a question for you. Can you spot which chest X-ray image has positively tested coronavirus? I don't think most of us will be able to tell just by looking at those images. The answer is those highlighted ones are the ones affected by coronavirus, tested positively using chest image. So here's a solution. Can we use computer vision, deep learning to help our medical professionals to more easily diagnose COVID-19 symptoms using X-ray? The answer obviously is yes. So I decided to approach this problem by building my own deep learning image classification model using a technique called transfer learning, or more concretely, fine-tuning. Fine-tuning is a real-world technique that most deep learning practitioners use when they build their own model. Instead of starting from scratch, we will use a pre-trained network with pre-trained weights, and then append our own custom-designed neural network layers on top of it to complete the end-to-end training. The benefit of using transfer learning is we can shorten the amount of time needed to build a model and to train a model to achieve certain accuracy. So for this particular problem, I choose to use Keras, TensorFlow, scikit-learn, and also Horovod to build and train my own COVID-19 chest X-ray image diagnosis solutions. This is a much more realistic and real-world facing solutions. Okay, I can show you the code on my test instances. In fact, I have chosen to publish this as an open source GitHub repository, which you can download the training program from my GitHub repository to run in your own environment. But in order to save time, I'm just gonna show you the result of running the training program in identical setting with and without AIACC. The right-hand side is showing the training progress using AIACC. The left-hand side is same training program on same dataset without AIACC. The circle part shows the difference between the two. In fact, I have repetitively tested my test environment for training this chest X-ray image diagnosis solution with various different configurations on a different machines, on a different GPU specification. And here are the summary of the performance difference comparison. In good time, I achieved more than 70% of speed increase using AIACC. On other settings, the improvement is in the realm of 20% also. The summary on that is we can help achieve identical training accuracy in much shorter time when AIACC is turned on. This is the training result after running the program for 50 epochs. Both with AIACC and without AIACC has achieved upward of 98% validation accuracy. However, the one with AIACC has cut short the time by as much as 74%, as you've seen from my earlier slides. Here's the published model after my training. I have included a quick demo for you to try my chest ray COVID-19 diagnosis programs. If you select a sample image from the gallery and say execute, it will call the model and run a diagnosis and tell you how likely this image shows the lung has been affected by coronavirus. Obviously, I made this for demo, and this is not meant to be a medical grade usage. However, you can tell the difference between the one with AIACC and one without AIACC, how helpful it is to help you get the model in much shorter time. Okay, going back to our slides. I previously mentioned I have open sourced my training program, my validation scripts for you to test in your own Alibaba Cloud environment. Feel free to clone the GitHub repo from the link attached here. So why does it matter? What exactly is the business value of AIACC? In real world, it means increasing the productivity and getting faster time to market when you build a deep learning-based AI solution. It is also to maximize the globally scarce GPU resources. The stock is only very limited. So every additional efficiency you can squeeze out of the existing GPU resources is going to help your business gain competitive advantages. What is the return of investment to our customers? I have created a typical example of what happens in real world when you try to build a deep learning model. Let's say I try to build an AI solution. The cost involved for me consists of number of workers I need to use to train my program, times my GPU specification. Obviously, the better, the stronger, the more expensive the cost will be. And also the total training amount of time. Now, when you times these three factors, that becomes your cost. Alibaba Cloud's advantage is on the hardware level, we set cheaper unit price compared to most major public cloud vendors. And by engaging AIACC, we can further help save the time required to train your AI solution to achieve the same level of accuracy. When you add these two together times the workload time and number of instances, that becomes the return of investment for using AIACC. Let's take a look at an example. Let's say I have a certain workload that I'm running on a public cloud vendor. I need 5 instances, each have certain amount of GPU powers, GPU memories, and the cost price is $24.50 per hour for running my computing instances. Let's say my training work requires 100 hours to complete. I will be paying $12,250 for completing my workload. If I migrate exactly the same workload onto Alibaba Cloud with AIACC using identical settings and identical computing resource, here's what's going to happen. Number one, you will be paying cheaper unit price for same amount of computing resources. And by using the AIACC, I can save my training time. Let's say that's 30% savings. When you times these two together, it gives you a compounded total saving of more than 60% for completing exactly the same workload. And that represents a huge amount of savings to my business, and I enjoy the benefit of faster time to market. And that's the key value of AIACC on Alibaba Cloud. So I have been talking a lot of goodies about AIACC. You may be asking, is it going to be very expensive to use AIACC? The short answer is it's free. It's completely free to use AIACC on Alibaba Cloud ECS. However, it is a proprietary technologies to Alibaba Cloud, hence you will be needing to turn on AIACC on Alibaba Cloud ECS computing instances. In fact, AIACC represents a very small part of comprehensive cloud-native AI suite. I've been talking about AIACC as a way to accelerate the GPU performance. However, we have much more offerings than AIACC to help you gain much better performance and productivity on Alibaba Cloud, which I will save it for another occasion to introduce you the details. Li Shan is a product expert who curated this cloud-native AI suite. For any further questions or demonstration of cloud-native AI total packages, you're welcome to reach out to our product expert, Li Shan. That concludes my introduction about AIACC today. I hope you enjoyed the demos and the value, and I hope you will be able to give it a try in your own environment. Thank you very much.